So this question wants us to find the amount of pure ingredient needed to prepare 800 milliliters of a 3% solution, sodium bicarbonate solution, from pure powdered sodium bicarbonate. Let's go ahead and highlight the important details here. We need 800 milliliters, and this needs to be a 3% solution. So let's start by thinking about what a 3% solution might mean. 3%, we can convert percents to decimals, can't we, by moving the decimal 2 places to the left. So 3% can also be written as 0.03 or 300ths as a decimal, which can also be written as a fraction as 3 over 100. And all of these sort of mean the same thing. And in the case of a 3% solution, what this means is that for every 100 milliliters of solution, we want to have dissolved in that 3 milliliters of our pure ingredient, of our sodium bicarbonate. So let's write that up as a kind of a conversion factor here. For every 100 milliliters of solution, we want to be able to dissolve in that 3 milliliters of our ingredient. And we'll just say ing, ingredient, there. Okay, so that is a conversion. That's sort of an equivalency that we'll use in our dimensional analysis setup here. The other thing that is often a good starting point is to start with what you need to prepare or to administer or something like that. In this case, we need to prepare 800 milliliters of this solution. So we're going to start with 800 milliliters of solution at the far left of our dimensional analysis setup, and we'll put that over 1. We're going to be working with a multiplication of fractions problem here, and to have a denominator of 1 makes this a little easier to sort of visualize. We're going to go ahead and multiply that by this conversion factor that we just set up right here. Remembering that we want to be able to diagonally cancel the units that we're trying to eliminate and be left with the units that we're trying to get to. We want to find milliliters of this pure ingredient. How much pure ingredient do we need? So we want to be left with ingredient on the top. We're going to diagonally cancel milliliters of solution. So we want that down here, milliliters of solution, and we want milliliters of ingredient up here. And now we can plug in our numbers for solution. We have 100 to every 3 milliliters of our ingredient. And at this point, we are ready to, we can diagonally cancel our units that way, and then just do the math. So numerator times numerator gives us our new numerator. We have 800 times 3, which is going to be 2400. And our denominator times denominator gives us 1 times 100, which is 100. Pretty easy improper fraction here to reduce down to the whole number 24. We look at what our units are that are remaining. We have milliliters of ingredient, so milliliters of ing, ingredient, and that is our final answer. So that sodium bicarbonate, that has a chemical formula here. It is NaHCO3. It's got some sodium and some hydrogen and carbon and oxygen, and sodium bicarbonate. That goes by the common name baking soda, and you probably have a box of this in your cupboard at home. So recap of the problem: it requires 24 milliliters of that pure powdered baking soda to prepare an 800 milliliter volume of a 3% solution from the pure powdered baking soda. Hope this is helpful.